We introduced Synthetica, a method for large-scale synthetic data generation for training robust perception networks for downstream robotics applications. In highly dynamic robotic scenarios, such as locomotion and manipulation, vision networks must ensure robustness to imaging artifacts, such as motion blur, varying lighting conditions, and occlusions, all the while also executing at real-time speeds. Our work focuses on the problem of object detection, which often serves as the bottleneck for most state estimation pipelines, such as pose estimation. We find that scaling up task-relevant data is key for ensuring robustness. Most existing object detectors are trained on real-world datasets. These are difficult to scale due to the prohibitively high cost of collecting and annotating data. As a result, this can lead to erroneous false positive detections. On the other hand, VLMs are trained on large, internet-scale datasets and display remarkable zero-shot performance. However, they are incredibly brittle when trying to detect objects, not to mention difficult to run in real time. Moreover, in trying to further improve benchmarking performance, many instance-level detectors sacrifice inference speed. The previous state-of-the-art method only runs at 5 Hz, and the fastest method can only run at 33 Hz. We evaluate our results on the YCB video dataset, which contains 21 different indoor objects. In order to generate synthetic data, we leverage Omniverse Isaac Sim, which contains a photorealistic real-time ray tracing renderer to generate 2.7 million images of the YCB objects in different configurations. In order to mitigate false positives, we also add distractor objects from other datasets such as Objaverse, Google Scanned Objects, and the Omniverse Asset Library. While generating data, we randomize various scene parameters such as object configurations, lighting intensity and color, and camera pose. We also randomize individual object material properties such as albedo, specular level, and roughness. In addition, we also incorporate training time data augmentations to increase the effective size of the training set. All of these randomizations and augmentations were added to ensure that the resulting dataset captured the wide range of conditions that are present in the real world. Using our dataset, we trained a real-time detection transformer model with both ResNet 50 and ConvNext small backbones. We utilized TensorRT to improve the execution speed of our networks by 1.5x for ConvNext and 2x for ResNet. Our network with the ConvNext backbone, trained on both synthetic data and the YCB training set, achieved state-of-the-art results on the official leaderboard with a map score of 0.885 and MAR of 0.903. It is also 1.5 times faster than the previous fastest method, while being able to operate at 50 Hz. With a map score 2% lower, our network trained with the ResNet backbone obtains third place while being able to execute at 100 Hz. With FP16 precision, we can achieve speeds of up to 230 Hz with a ResNet backbone. While the YCBV dataset makes use of laser-scanned objects, we also present a pipeline for collecting data on objects with no prior object models. First, a complete scan of an object can be made using the AR Code Object Capture 3D Scan app, available on all iPhone Pro or iPad Pro models with a LiDAR sensor. The resulting scan can then be converted into USD format and brought into Isaac Sim for data generation. Even though iPhone scans are not as high fidelity as laser scans, they suffice for the purposes of data generation. This data can then be used to train the detection network. We demonstrate the effectiveness of our pipeline in the real world. Using random grocery store objects, we are able to get object scans and use them to train a detection network. Our trained network acts as the front end for foundation pose, which gets the 6th pose of the objects. The pose is then used to facilitate object pick and place. Our network ensures that the pose estimates are robust to different amounts of lighting, blur, and occlusions by providing accurate region crops to foundation pose. For more information, please visit our website.